This lesson is Algebra 2, 5.3, rational exponents and roots. Rational exponents are exponents that can be written as a fraction. We'll look at examples, so don't panic, but that's what the definition of a rational exponent is, one that can be written as a fraction. And then roots, some that you're familiar with are probably square root and cube root. Square root, if you are using a phone calculator, it will show up like this. It has a little 2 on that hook. This number will tell you what root it is. So this is a square root. This is probably the most common. This one's a cube root. There's also a 4th root, 5th root, and 100th root. Anything you can think of, there's that type of root. It's really important that when you're writing roots and powers, you make sure that your script is very small. To make sure that we know it's a 3rd root, for example, to make sure we know that it's this, you have to make sure that 3 is on the tip of the hook. If you write it this way, that looks like 3 times the square root of something, and it's totally different. So script size is very important in this section. Rational exponents are a equals m over n, and this is how it's split up. If you think of it like a tree, it makes a little bit more sense. In a tree, the roots are on the bottom. And in the fraction, n is the root. They're going to be on the bottom of the fraction. And then, this doesn't work for a leaf analogy, but if you think of like government, for example, the power is in the top. So whoever's on the top has all the power. So the power is m. It also looks kind of loopy right here, like the loops of the leaves. I don't know if that's helpful, but the more helpful thing is that roots are on the bottom. In these examples, these are very common ones, as I mentioned. X to the 1/2 power is the same thing as the square root of x. But if you were to write it to get in the habit, we'd have 2 on the root, and then it would be x to the 1st. No one ever sees it this way, they always see it this way. X to the 1/3 power, 3 is the root, 1 is the power, so we would write 3 on the root and 1 as the power. For this third example, 2 is on the bottom, 2 would be the root, 3 is on the top, that would be the power, so we would have the second root or square root of x cubed. Again, you probably would never see that. What you would likely see is the square root of x cubed. But these are the same thing. If we look at a couple examples to practice rewriting, 27 to the power of 2 over 3 can be rewritten as the 3rd root, because 3 is on the bottom, of 27 squared. This part is able to be typed into a calculator, but the cube root of 27 is 3, and that would be 3 squared, which is 9. In your calculator, you would type in 27 caret parenthesis 2 divide 3. This would be rewritten as root 3 cube root, because 3 is on the bottom, 8 to the 5th power. The cube root of 8 is 2, and 2 to the 5th power is 2 times 2, which is 4, times another 2 is 8, 16, 32. Again, you could type this in as 8 caret parenthesis 5 divide 3. And then this one can be 16 to the power of 7 over 4 can be rewritten as a 4th root, because 4 is on the bottom, of 16 to the 7th power. The 4th root of 16 is 2 to the 7th, is 32 times 2 is 64 times 2 is 128. 2 to the 5th we knew is 32, so I just doubled it twice more. Or you could go 16 caret 7 divided 4. Now something to note in this box here is these are common inverses. These are inverses. They result in x. Ultimately, when we're solving for x, that's what we want. So if you remember back to our previous lesson, when powers are stacked, you multiply. 2 times 1/2 is 1, which is just x. 4 times 1/4 is 1, which is x. 3 times 1/3, also 1, which is x. This one looks a little bit weird, but you still multiply them. Multiplying fractions looks pretty bad, but it's actually kind of nice. You just do 3 times 4, which is 12, over 4 times 3, which is 12. That's x to the first, which is also x. So basically what you do is look for the reciprocal power, and that will solve for x.